Hello there, Charger family. Welcome to Mrs. Boyd's Math Room, featuring me, Mrs. Boyd. I hope you're fantastic. My cat currently is behind me trying to escape the house through the air conditioning vent. You know, I mean, it's the small things at this point. Today we're talking about angle measures. It's going to be real straightforward. I think you can do it. First, we're going to name angles. So let's give you some words here to go with this. An angle is formed by two non-collinear rays, which consists of an endpoint and arrow. Oopsie, that have a common endpoint called a vertex. Let's put that all in one spot. So again, an angle is formed by two non-collinear rays, an endpoint and an arrow that have a common endpoint called a vertex. So on this angle that you're looking at, you've got two non-collinear rays, ray BA and ray BC. They're two rays not on the same line. An endpoint at B and an arrow that goes through A. And they have a common endpoint called the vertex. The vertex is where B is. Like this says, this angle can be named four different ways. Way one, we're going to name it always with the vertex in the center. So angle A, B, C. We can do another way. We can go another way and put the vertex in the center, CBA. So that's another name for this angle, CBA. This particular angle also happens to have a name right here in the center, angle 2. So we can call it angle 2. Last but not least, we can call it just by the vertex since there's only one angle coming from this vertex. So this is angle B as well. Four different names, one little angle. All right. Interior and exterior angles. Moving on down. It says here, interior points are on the inside of an angle. And opposite, and not surprisingly, exterior points are on the outside of an angle. So I've given you an angle here, angle ABC or CBA or angle B. And we want to know which of those points are interior and which points are exterior. Well, it's not going to be surprising for you to know that if ABC is the angle, if we were to close it up the shortest distance, so bring A over to C this way, that's the inside of the angle. So the inside points, the interior points, are going to be points G and D. The exterior points on the outside of the angle are going to be points F and H. A little bit of more things that you probably will remember from previously. An acute angle is not just really good looking. That means it's less than 90 degrees. So the angle has to be greater than 0. And it has to be less than 90. So in this case, this is the measure of angle A. Has to be less than 90. You can't really tell from my handwriting because it's atrocious, as you know. But let me make this a little bit more clear. The less than signs looks eerily similar to angle signs. So a less than side should point right at the center of my word. So that should be 0. Now I'm really getting confused. And then the measure and the angle should kind of lay on the same line as the words. Angle A, and that's less than 90. A right angle, let's going to give us that little half box here, kind of a full box, but really a half box. And it's equal to 90. So the measure of angle B is equal to 90 degrees. An obtuse angle is greater than 90 and less than 180. So the measure of angle C is greater than 90 and less than 180 degrees. Flip it on over. We'll learn some more goodies about angle measures. There's an angle bisector here at the top. And I'm going to use some words to define it here. So this is a ray that divides an angle into two congruent and equal angles. So an angle bisector literally is just a ray that splits an angle exactly in half. All right? So this says if ray DG is an angle bisector to CDF, that means if DG, oh, for Pete's sake, is a bisector to CDF, then we can say that angle CDG is congruent, that's what that means, to angle GDF, and the measure of angle CDG is equal to the measure of angle GDF. We can also say the measure of angle CDG is equal to 1/2 the measure of angle CDF, because DG splits CDF in half. So CDG has got to be half of CDF. And congruently, the measure of angle FDG has got to be equal to 1/2 the measure of angle CDF. All right, so essentially, it means that this angle and this angle are the same. Next, angle FA, a ray FA, and ray FE are opposite rays. That means they're heading in exact opposite directions. Ray FB bisects AFC, and ray FD bisects CFE. That's telling us, let's make some notes here, that AFB and BFC are equivalent. That's also telling us that CDF and DFE are equivalent, hence the little 2 hash marks. So now we're going to use that information to solve these problems. We've gotten the measure of angle AFB equals 3x plus 4. So AFB is 3x plus 4. And measure of angle BFC is 5x minus 7. Find x. Well, we know that the measure of angle AFB is equal to the measure of angle BFC, because they are bisected by ray FB. So we'll plug in what AFB and BFC are. We've got 3x plus 4 equals 5x minus 7. So we can solve here. Let's add 7 to each side. 3x plus 11 is 5x. We subtract 3x from each side, and we get 11 equals 2x. Divide by 2, and x is 11/2. You can just leave it as a fraction. So we know that x is 11/2. We want to know what angle AFC is equal to, so let's plug that in. We know that the measure of angle AFC is equal to the measure of angle AFB plus the measure of angle BFC. So we know that the measure of angle AFC is equal to AFB is 3x plus 4. So we get 3 times 11 over 2 plus 4 plus 5 times 11. Oh, it's an 11 over 2 minus 7. Now we can just solve. We've got 33 over 2 plus 4 plus 55 over 2 minus 7. Well, 33 plus 55 is 88. 88 over 2. And then 4 minus 7 is minus 3. Well, we can make 88 over 2. We can divide that. That is 44. And 44 minus 3 is 41. And that is the measure of angle AFC. Kind of long and drawn out, but we totally did it. We knew exactly what to do. Last but not least, measure of angle CFE. CFE is 8x minus 10. And DFE is 3x plus 2. We want to know the measure of angle CFD. So let's write down what we know. We know that the measure of angle CFE is 2 times the measure of angle DFE, because CFE is split in exact half by ray FD. So DFE plus DFE is CFE. Let's plug in what we know. Measure of angle CFE is 8x minus 10. And that's equal to 2 times DFE, 3x plus 2. We can solve for x. 8x minus 10 is going to stay the same. We distribute that 2 and get 6x plus 4. Let's subtract, that 6x from each side. And we've got 2x minus 10 is 4. You can add 10. 2x is 14. Divide by 2, run out of space, and x is 7. It's halfway there. Now we want to know CFD. So the measure of angle CFD is equal to the measure of angle DFE. So the measure of angle CFD is equal to 3 times 7 plus 2. Wrong parentheses there. Let me fix that. So that's 21 plus 2. So the measure of angle CFD is 23. Yay! I know you can do this, my brilliant babies. Let me know if you have any problems. Reach out if I can help, and I'll see you very soon.